Thank you, James, and thank you all for joining us today. My name is Stefan Mordue. I'm Senior Consultant for Cohesive. I'm also the Academic Director for the Masters in Global BIM Management here at ZIGURAT, and I'm delighted that you can join us for today's session. So, our construction industry, we are at a tipping point. We have a skills gap, we have an aging workforce, we have productivity issues, we have old and often failing buildings and infrastructure, and all of this is against a backdrop of increasing pressures of global climate crisis. So our built assets, they need to be safe, they need to be reliable, and they need to be fit for purpose. Now, we've already seen that the impact of BIM is having on the industry. We've got better information, better collaboration, and ultimately better performing assets. And I think that this will only continue as we see it being combined with better technology, the Internet of Things, and also digital twinning. So while these add value, when we start to consider the potential impact that artificial intelligence can bring, it's only our imaginations which will hold us back. I think we'll start to unlock the value in construction data, which is often trapped or it's unstructured. And then we can begin to gain greater insights and make better decisions. So the concept of AI isn't new, but unlike other technologies, the pace of which AI is moving doesn't seem to slow down anytime soon. We're starting to use apps such as Chat GPT through to complex algorithmic based generative design software. So the use cases for AI in construction will only increase, but we do need to be mindful that we use it in an ethical and a secure way. So without further ado, I'm really delighted to introduce to you today Oana and Angelos of infrared.city, who will be showcasing and discussing just some of the exciting developments in AI for construction.
Thank you very much for the introduction, Stefan. Delighted to be here. I'm Angelos Chronis. I'm the CEO and co-founder of infrared.city, and I'm here with Oana.
Hi, thank you very much, Stefan. Thanks for this very interesting introduction and setup of the discussion today. My name is Oana Taut. I'm an architect and researcher in the field of AI for architecture. I'm also a co-founder and the CPO of infrared.city, where I am already leading the product effort and ensuring global AI-powered simulations available for urban climate resilience.
So without further ado, I will actually start sharing my screen and let's kickstart this presentation. Infrared.city is a startup that focuses on AI-driven climate simulations for sustainable urban and building development. And we're pioneering the use of AI to make climate simulations accessible to everyone in the design industry. Um, Before I talk about infrared and the projects that we're doing, I'd like to start with the problem, which by now we're definitely all experiencing. Climate change is here and it's right in our cities, right in our lives. We used to use these figures from 2021, a devastating year for the climate, to present and pitch the idea of infrared, the AI-driven simulations that we are developing. But I had to update these figures and these images with what happened this summer in my home country, Greece, where within just over a month we lost billions of acres and more than 5% of the GDP in productive agricultural area. 150,000 animals were killed, and that's just in the course of just a month. So the problem is a very real one, and we need to address it from all sides, but specifically from the urban development side. So we all know the urbanization rates are not stopping. By 2050, 70% of us are expected to live in cities. And what Autodesk says is by then we have to actually build 13,000 buildings per day. Um, Even if we take the sort of like more optimistic calculations, we are still one of the largest contributors to climate change. More than 40% of climate change is attributed to the built environment. More than 60% of carbon emissions are generated in cities. So we definitely need to find ways to understand the impact that our designs, our plans, our urban and city plans and our buildings have on the environment, and vice versa. What will happen to our urban environments and to our cities from the climate? And to do that, we need very complex, time-consuming climate simulations. Climate simulations are very expensive. They're very difficult to integrate in design. Simulation software is normally very inaccessible. So, in a nutshell, that's what Infrared City is trying to do. We're trying to make climate simulations accessible using artificial intelligence.
So infrared uses AI to predict climate simulations in real time. So while one of these typical wind comfort simulations that is very important to understand the effect of our building massings in the built environment may take up to three days to produce by an expert, and of course have a very steep cost associated to it, with infrared you can generate AI-driven, AI-predicted simulations in under a second. Next. Here you can see the accuracy of infrared cities models at the moment. We are able to predict simulation results with approximately 90% accuracy at less than 1% of the cost. On the left side, you can see typical annual solar radiation simulation that can take up to 30 minutes. And on the right side, you can see the same setup and the same simulation predicted by infrared cities models. One takes 30 minutes to produce and the other one takes less than a second. So the reason for using this inside the design process is already quite clear. Next. So how we achieve this? We train deep learning models with thousands of simulation results that are trying to capture very wide variety of building massings that are possible to happen within a city. And with these trained models, we can then predict simulations for never seen designs. But it's not all about our AI models and the prediction of the simulations. What actually drives us apart from this is increasing the accessibility. So for this, we are approaching it with an open integration framework. Our app currently, or our predictions currently, are available through Cloud App, CAD plugins, and APIs. Next. Infrared is currently a working platform. It's fast, integrated, and doesn't require expertise to use. Next. On the platform currently, you can predict wind speed and wind comfort simulations, as well as solar radiation and insolation hours. We are also adding more services that are required for the built environment in the next development. Extremely accessible, the Cloud App allows users to quickly create a project by adding their information, their project location. They can instantly retrieve data that is available about the context of the design. They have a set of tools on the app to set up their site, set up the simulation requirements, and begin drawing or creating a building instantly. They can also import designs from other apps or other design platforms. And in almost real time, the wind simulations or the predictions of the simulations are delivered back to the user. If then a design change is necessary based on the results of the simulations, the same simulation can be re-evaluated again with the new design change. and it is possible to check whether improvements have been made, or how to inform the improvements in the design process. So it's very easy to imagine how by increasing the speed, we actually enable simulations to be used within the design process. Next. Next, we have the Grasshopper plugin. Next. This allows more advanced users to build internal design generation applications, or to enable existing workflows that they may have created internally with simulation results. So while simulations are part of what the available tools that Grasshopper can allow design teams, because of the slow computation aspect of some of the simulations, they are very difficult to use in a generative design workflow. What we can do is by embedding infrared in Grasshopper is to enable this sort of simulations with the use of AI to be embedded into generative fast design processes. Next. And finally, by accessing our API, users can build and deliver custom applications to access the simulation results. Here you can see how Giraffe, a very popular design generation and testing application, included simulation results as a service directly on their own platform.
In a nutshell, what infrared allows us to do is to really serve simulations in every design platform, in every design system, through this open integration approach, but at the same time to deliver real-time and accurate enough climate impact simulations for design processes. What I'm going to show next is essentially a project we've done as a collaboration between infrared cities, models, and AI-driven simulation capabilities, link architecture as a design partner. And well, all of this was happening during infrared's time within the Austrian Institute of Technology and the City Intelligence Lab. So infrared is a spin-off of AIT, and therefore this project happened within AIT. So what we can see essentially in this project is how parametric design, fast iterative design changes are combined with microclimate and accessibility and other environmental factors to really be able to assess in real time and in an interactive way the performance of a project. In this case, we're talking about the waterfront redevelopment, and what we can see here is essentially a generative design, parametric design module that allows very quickly to play with street layouts, with mass, to add and remove mass, and very quickly to generate sort of like different options for this project, different options for the development of this area. And these sort of like design, fast iterative design changes don't come just with sort of like metrics about the form, but also with metrics about the climate. So every time a design change happens, infrared city, the AI models of infrared city are triggered automatically to generate immediately microclimate analysis of every new design. So it means that any sort of design change carries with it enough information of performance to actually be able to be assessed in times that would previously be inconceivable. Just a quick example here of moving a park around, which we saw a little bit earlier when I was describing the Grasshopper integration. So in this case, we just select a point within this sort of like island massing option to move around the park. Every time we move around the park, and this is a real-time sort of recording, we can actually see on the left side the wind comfort charts being directly updated. So moving a street layout and changing, essentially cutting off a street immediately triggers a wind comfort simulation. We can see how these big sort of like series of buildings shelter from the wind comfort from the high winds. This is Norway. This is a coastal area. They have very high winds. How it shelters essentially this sort of like small square park that we introduce. So every time a design change is happening, a simulation is triggered. But it's not only about essentially wind comfort. In this case, we've done in this project, we've also combined it with accessibility and mobility analysis, which is not what Infrared is currently offering, but it's something that we will probably be offering in the future. So essentially, here you can see where parks are located and how access to those parks is calculated. So for every sort of design change, every time we move that park around, we can calculate the time it takes to go to these parks from every unit in this development. At the same time, we can put in stations or sort of like a tram line or any other transport line and see accessibility and catchment areas of these stations. These sort of like models are currently available from the Austrian Institute of Technology, which can be integrated directly with infrared city. You can even look at things like footfall of different bridges that connect these stations and look at passenger potentials or walking time to stations from each sort of like unit in this area. On top of that, you can also do things like noise simulations, where this is something we're going to introduce very soon in infrared city as an AI model. In this case, it's not really an AI-driven model, but we're building that as well, where you can actually see every unit's sort of like exposure to high sort of like noise and what sort of population percentage is exposed. So this idea of this holistic real-time analysis of designs really changes the way we interact with massing in this sort of like relatively large urban area. Further to this iterative manual search for a performative solution, what we can also do, which was also previously attainable, is to actually search a whole design space. So what we can do further to this iterative manual search for a performative solution by adjusting design components, we can also explore using generative design a wealth of sort of like design options. And in this case, I'm just going to show a project we've done where we are actually searching for the best solution using four fundamental performance metrics like thermal comfort, wind comfort, footfall, like essentially accessibility through the quarter and access to quarters outside of our quarter at hand. And in this case, what we can do is essentially run 1,000 potential scenarios, potential design options, and not just create the geometry for them, but also create the performance of each one of these options. And then that means that we can really sort of like select the best options, take them to the design table, and continue to manually interacting with them. So this idea of human to AI interaction is what's very interesting here. So you can take that design that's very performative, bringing back to the design table, and this is also start saying, I'm going to continue designing from this sort of like very performative base. And in this case, what we say is, let's find where we should put a tower. And that tower can actually be like searching for its own location by checking the wind comfort so that it minimizes the wind comfort, but also does not affect the circulation of that quarter. And that's essentially, again, something that was not previously attainable, because if you were to run all of these different analyses, it could take you months, while with infrared, it takes you less than a day. So to conclude, essentially, what infrared can deliver is real-time performance assessment, which essentially revolutionizes the way we use simulation in design. Instead of having certain assumptions and waiting for the simulation to validate those assumptions, we can actually design with simulation, design with comfort, something that previously was not possible. On that note, that concludes the presentation.
a really fascinating insight, and it's great to see some real world examples. And for me, I think we've seen the devastation that Mother Nature, the climate can cause. I think you've seen that in your home region in Greece. So I think what you're doing here is really, really valuable, and it has an impact so wide reaching. Um, I mean, I've seen some fantastic stuff. You were saying, 90% accuracy for, 1% of cost. You're talking about decision making, you know, getting results, real time changes, and seeing what that has on our designs. But I guess the question I want to ask you is, what does all this mean for designers and architects and engineers? And do you think, is there a skills gap that we maybe need to address to adopt some of these processes and technologies?
Certainly. Thank you, Stefan. Angelos, I don't know if you want to take this, but if not, I'll respond with my insight. And basically, what infrared is really trying to achieve is to make simulation or accessible to any user in the built environment, any decision maker in the built environment, independent on how specialized or how developed, how what kind of size of a company we are talking about. So we are trying to address from the very small office to large offices and enable them to use simulations within their design process. Now, in regards the skill gap, definitely this is one of the topics to be addressed. We have been collectively as an industry talking about climate change and trying to embed some sustainability measures in our building for a large number of years now. But I would say that this is still gaps. This is still skill that needs to be built in our industry, in learning what sort of data to access regarding their buildings, at which stage to access this data, not only how to access it, but also how to interpret and how to use it to inform the design towards a more sustainable, more balanced, or more performative option.
If I may add a couple of words there, I totally agree. There is potentially there's a gap. I'm not entirely sure if it's a skills gap or if it's a sort of like integration and innovation gap. You probably all have heard the very famous sort of like stat that we are the second least innovative industry, while we are like one of the largest ones. From my end, I come from an era where like essentially anything like connecting a climate simulation to any sort of like CAD system was actually almost close to rocket science, and that's like not really that far ago. That's like maybe perhaps like 15 years ago was already like very hard to do so. We've seen leaps of progress, but we need to see a lot more. So it's also partly our fault, like the tool developers to do that. There is proprietary and sort of like gaps of sort of like integration in our industry and how we actually use files. But one of the things that I perhaps want to say very clearly is we don't have time to fiddle around anymore. We are responsible for these 40%, and we need to feel responsible when we actually put the responsibility into the value of what we are delivering at every sort of new development that we generate, any sort of like proposal we do to a city. We actually need to have that responsibility. We'll actually move things a lot faster. That's one aspect, and the other for me is integration is key. One of the reasons that Infrared is taking this approach of open, full integration, users can actually take our API. You saw Giraffe essentially very quickly integrated our simulation models in their design system. We believe that this is the only way to actually deliver that value fast, efficiently. We don't want to lock in people in a design system. We actually want to integrate simulation in every design system, and that's a fundamental sort of like approach that we're taking.
Fantastic. So it's about integrating with large data sets and I guess ingesting that information. With that then, is there anything we need to consider from maybe an ethical standpoint or from a security standpoint as well, you know, when we're dealing with maybe sensitive data or data of that nature?
Yeah, Owen, I will give it a start, and then perhaps you can chip in afterwards. I definitely think, you know, we're at a very critical stage of AI development, and we need to definitely think of the ethical sort of like considerations at any step we're making. My two cents on that is essentially that when we're talking about climate simulation, when we're talking about climate adaptability and resilience, when we're talking about how our cities and our buildings will essentially adapt to what's coming, and what's coming is actually not really sort of like very positive, very optimistic. What we need to do more is actually have more open data approaches, more sort of like data sharing. I normally we also teach AI to architects and planners. We are involved in educational programs that do that sort of like gap sort of bridging. And well, one of the things that we very often see is like if you use something like social media like giants like Google or Instagram or Twitter, like any sort of like social media data, you might actually find that they know more about our cities than our cities actually do. Like the data that cities have about their own operation is insanely less sort of like than the ones that like big IT and technology operators have. So there's definitely a question there where we stand in terms of like the ethics of sharing this data. And there's of course the issue of personal data and personal identification, which we are completely against and we don't ever use in our sort of like approaches. This is not something that is needed in order to understand the climate sort of like resilience strategies that you need to take. So from I think our perspective, the ethics question lies more on who and why owns the data and why this data is not really available to every researcher, every scientist, every company at the end of the day that needs to progress and develop solutions like the ones we're offering in making cities more resilient.
Perfect, thank you. So there's obviously a lot of people.
Yeah,
Oh, sorry, Anna, after you.
Yeah, no, I wanted to add that I think indeed discussing ethics in the context of AI is definitely crucial and of major importance. However, I would say that in the industry, in the field that we are operating in, data that can be released is not necessarily of high
Is it reliable? Good
sensitivity.
quality? Right.
It's
Okay.
not necessarily of high sensitivity to individual users, and also there is at no point the need for identification, right? So the data anonymity can be extremely high, and our systems will not lose anything in terms of accuracy. So from this point of view, obviously that the common good would require us to share to as an industry, um, adopt a more open view towards data and towards sharing.
Thank you. So obviously, infrared, you've been on a fantastic journey today. I'm sure you've learned lots of lessons along the way. For people listening for us today, is there any kind of practical steps or tips that you could give us if they're maybe looking to maybe introduce AI into their business, into their processes? Is there any tips that you could embark on us?
Sure, I can give it a start, and Oana, please, yeah, correct me. The first tip I would say is to be open to innovation. Like our industry is notoriously closed to innovation. I'd say don't hesitate to try to integrate AI models, AI tools, in design processes, in design systems. That's probably the best way forward. And well, to innovate, education is key. I would definitely expect companies and organizations to want to equip their teams with cutting edge sort of like skills for AI development. As I said before, we teach sort of like AI in universities as well. Currently, I'm directing a new master's called AI for Architecture in the Built Environment, and one of the things that I normally say to students is like, that's very interesting. Actually, it's like every year it's not like the type of subject where you have like develop a curriculum and then you say, okay, I'm going to teach this for the next 5 years. Every year you teach new things, so there is no way you can reuse a curriculum for the
It's
next
changing
year
so
because
fast, isn't it?
it's changing so fast. It's actually incredible. You can't even keep up yourself. So there will be of course there is this sort of like AI anxiety, like can I catch up, can I actually get there. But there's also like so much development going on right now that very soon no one will really need to code anything. No one will really need to be a programmer to use AI. You'll literally be able to use a grasshopper style sort of like battery connection to do very, very deep and complex AI training and AI models. So we're going to get there. So the sooner you adapt these AI tools, like Infrared, for example, is the best that you can actually, you can be ahead of the curve. That's the main sort of like, and say, try things, they're there.
Yeah,
Brilliant.
I think one small thing to add from my side here would be that indeed our AI tools for and specifically created for architecture and design are, to say the least, not mature, right? So we are definitely at a very incipient stage, but indeed we rely as tool creators, we rely on the industry to make the choice to adopt, to be fast adopters. But at the same time, it's valuable for the industry itself to become these early adopters of tools, and knowing that they will help build the right tool for the industry, rather than be a laggard, and be forced eventually to adopt the tool that's available. No, so I just wanted to add one thing that, of course, a lot of the let's say that the contrarian views about adopting AI in architecture focuses a lot on maybe accuracy or topics of indeed ethics or correctness or legality of these tools. But to use the words of one of our clients, if an AI tool can help us be 1% right rather than 100% wrong, I would take it any day, right? So my advice would be to simply start by being open and adopting some of the tools that are available.
Brilliant. Thank you. I think I'll probably leave it there with that profound message. So again, keep it simple, adopt the technology that we've got there. So if anybody wants to find out a bit more about Infrared City, it's infrared.city. Is that right? That's the web domain. People can go over and have a look.
True.
Perfect.
And they can just email us as well. It's our name, Angelos.Chronis at infrared.city or Oana.Taut at infrared.city. People can just email us if they want to know more.
Brilliant. Well, thank you very much to two excellent speakers, and thank you very much for sharing your journey. And it was really insightful. I've learned an awful lot. Thank you very much for tuning in today and being part of Construction Week 2024. If you want to find out more about our courses at ZIGURAT, whether that's BIM, whether that's AI, please head over to the website. We've also got lots of fascinating other talks, other seminars that are going on over the next few days. So please do make sure you sign up for those. And thank you very much for your time. And until next time, stay safe and hope to see you soon. Take care.